All right, so we're back. Right, I was thinking about recursion last night as I was going to sleep. Yeah, that's my life now. And I was thinking that to me, right, in my mind, I think in loops. I think in for loops and while loops instead of recursions. But I think that since they are fairly similar and you pretty much achieve the same goals just through different means. So changing the way you think about how to solve a certain problem, I think it's okay for now that I keep thinking in loops. I just reiterate that this is recursion. Yeah, it's all one. It's all put together, right? This is one recursion. It's put all mushed into one thing. While loops is very separate and you can mess things around, but I think it's okay. Alright. Volgadinotap asks, why wouldn't the politicians enjoy Haskell? They might, but it's not what they came for, I don't think. Hello, Aaron Zero. Nice to see you again. Remove the K and D. It becomes a hassle. Wait, the K... Wait, remove what? Nice to see you, Ban. Again, by the way, Aaron Zero. The K and D? There are no K's and D. What are we talking about? Colgate Innosabs says, we discuss politics here. Yeah, we do, but we're focusing on Haskell. So we could discuss the politics around Haskell. Between the difference, should we have recursive functions or loop functions? I don't know. Remove the K and. I am super confused. What K are we removing? Hassle 3? Wait. Oh! Remove the K from Haskell and it becomes a hassle. Oh man. Yeah, if you remove the K, it becomes a hassle. Yeah. I would say that you don't even have to remove the K. It's still a hassle. Oh man. Sometimes. Alright, a few more recursive functions. Now that we know how to generally think recursively, I mean... I know theoretically kinda how to do it, but practically it's gonna take a while. Yeah. Let's implement a few functions. We did this yesterday. First off, we'll implement replicate. It takes... Yeah, we did this. 42 3 times. We use guards here instead of patterns because we're testing for a Boolean condition. Right, yeah. Pattern was just equality, right? Wait, no. Was pattern always equality? I don't remember. Or was... We could check for a pattern included within. I don't remember. I think we checked for equality. Yeah, I'm pretty sure. If n is less than equal... Wait. Then 0, return an empty list. Otherwise, return a list that has x as the first element and then replicated n minus 1 times as the tail. Eventually, the n minus 1 part will cause our function to reach the edge condition. Exactly. Right, now num is not a sum class of ord. Yeah, we needed both of them. I remember that. Yeah, we need both of them in our class types, if that is indeed what we're doing. Colgate Innotab says pattern matching checks for matching pattern. Right, my mind, when we talk about pattern matching, always goes directly to regular expressions, right? So, for example, let's... oh, I don't even have... stuff, learn, yeah, alright. Let's say we to... what's it called? Was it this? The HCI? No, what was it called again? Fuck, I forget. Well, it's right here somewhere, isn't it? Great song. GHCI, there we go. GHCI. Whoops. Wait, what's happening? That was weird. Right, we can have a pattern like this. Hello. Right. Do I have to do a function for this? With regular expression, we could just do... how do you do that again? Something like this, and we could get a pattern match, right? That is what I was thinking about. I lost track of where we were. Here we go. Oh, right. Thanks, Colgate on tap. Yeah. It says that, like, if we take 8 and then comma underscore, that matches any pair with 8 as the first element. Exactly. Yeah, we use the underscore as anything. Yeah, so we can pattern match to any pattern. We can decide to care about some things and not care about other things. Thanks. That's what I wanted to remember. Yeah. But yeah, it is very similar to regular expressions, just not only for strings. They are for... It's more of a pattern match within all kinds of things. And probably when we're looking at specifically for strings, it becomes a little less, right? Since it's not as specific, we will lose some functionality, but that's okay. Aaron Sarah asks, have you played Star Wars, The Old Republic? Is that the MMO or is it the... No, Knights of the Old Republic is the old games, right? That people are that people really liked. I haven't played either, so I think I started the MMO for like 5-10 minutes. I had plans of playing it, but at that time in my life, I was not in that mood set of playing through a storyline. I just wanted to grind out, and so I bounced off it. I might go back just playing through the storyline because I hear the MMO has a good one. Yeah. It's the MMO, yeah. Just the Old Republic. Exactly. Yeah, Knights of the Old Republic are the older games, not the MMOs. KOTOR. Alright, next up we'll implement take. It takes a certain number of elements from a list. For instance, take, and it takes the 3 first one. We'll return 5, 4, and 3. Yeah. If we try to take 0 or less, oh, actually, I think I know how to do this. Do I want to try and implement it myself, or should we just read how it's done? Do a practice thing? Alright, if we go cd in my stuff, we have learn me a Haskell real good. And we can, with Vim, we can open our test. Wait, why is there a 2 thing there? We must have compiled something into 2? I don't know. Colgatinotab says, try yourself. Let's do it. Alright. get rid of all of this, and I immediately forget the syntax. Right, what was it that we were gonna do? Take. Yeah, we want to implement take, which we will take. Right, we can just do this, a list of anything into this. No, a new list of the same thing, right? We get a list input, a list output. Damn it, it's a good thing writing this because the syntax, I don't know the syntax, so we'll try it out. Aaron Zero says, it is really good. There are main classes to choose from, each with their own story. 8 main classes. Right. If you would, have you played all of them? Or from the ones you have played, if you have played more than one, which one would you recommend for someone who just want to play it through? For the storyline and then for the game, like, yes, gameplay and story-wise, I guess. Is that really how you did it? I don't remember. I guess we do it science way, right? We will try and load it, and whatever error we get, we deal with. All right, we take a list, right? No. If we get an empty list, we do what? Shit, this is our edge condition, right? What do we return? Nothing? Shit, I don't remember. And this is where we want to stop. All right. Let's just start like this. All right. List is now empty. List is empty. Something like that. Aaron Zero says he played only 2. Neither of them you finished yet. Oh. Right, and here we have the actual recursion thing, right? Where we take... Wait, can you do this? Like... That's how they do it, right? When you take the head, this is the head and this is the tail. We do this recursively, right? But we don't care about the tail. So we just take the head. Right? And we put that into... Wait, what? Shit. Don't we just... No. We need a number as well. Yeah, we need how many we take. So we need a number and a list, right? So we take... How many times? Which order do we place them in? We take a list and a number. Wait, this has to be a num, right? Oh, it even has to be an integer, doesn't it? Integral, I mean. Colgate Tab says you can do it without typeline, load it, and use T2 type to make GHCI to give it for you if you don't remember the syntax. Yeah, take. Oh yeah, I've written take. I'm just thinking that we need... I mean, I could skip this. The type line. I kind of want to write the type line though, because we do... Right, we need num b, let's call it that, just to make life easier. And And we take a list. And we take... There we go. That the order? Okay, didn't... yeah. Aaron says, I'd play as a Jedi or a Sith if it is for your first time, because, well, lightsabers and force abilities. Who wants to use blasters? Uncivilized. Oh, I like that, Aaron Zero, yeah. Jedi or Sith. Oh, man, that becomes an interesting choice. I would probably play as a Jedi because for some reason, I love being a goody two-shoes in games. Wait, are the Sith evil in the game, by the way, since you play as a Sith? Or is it more like the World of Warcraft thing, where the Horde is the good guys and the Alliance are the bad guys? Colgatinotab says, or another way would be to use :T, take on a built-in function if you have trouble. Oh, but that kind of feels like cheating. First try to... I get what you're saying. That's one way, so we don't, instead of going over here and scrolling down... Or actually, we just saw it. I saw it right here. Alright. That's one way of doing it, I guess. Right, what are we doing here? We... Do we make a list comprehension for this? Is that what we do? We just put in X. Is that how it's done? I don't remember. Can we just... I mean, we need to get a list out, so a list comprehension would probably be the way to do it, right? So we take X and... Right. In X... Right, something like this. Shit, I don't remember the syntax of... Well, the X here is confusing, isn't it? Maybe just set an I to make sure. We take X into I, like that. And then here is the recursive part, right? Where we want to... No, shit. Here we go. We take... Yeah, we're taking X. You know what? This is annoying. Let's just take a list. Let's just take a list instead, right? So from here, we... Shit. Right? How do I get the head here from the list? I don't remember. Colgatinotab says, Typeline gives you lots of info about the function, but I don't think it spoils too much. Yeah. It was just the syntax, right? It doesn't spoil how to do it. Sarah says, also I have not gotten that far into the story, so I can't say that much. Are you playing it right now? Is that what's going on, Aaron Zero? Part of me is a little bit surprised that the servers are still up on this game, but on that game, but at the same time I'm not. Yeah, the thing I'm stuck on here is the list comprehensions. Right, what I want to do, just to make sure, is that we want to, right, we have a list, and then we take a number, right? How many are we gonna take? So here is this is our equivalent to our B here. No, this is our new list, right? We make a list comprehension. We make a new list and we put I here, and what I is gonna be the head of this list. Yeah. Oh, actually, and we do care about the tail. Yeah, we do care about the tail because we're gonna use the tail recursively. Which I don't... Yeah. Which means that we need to do what they did over here. Yeah, we need to take... We need to take this. Right. Right. Here we do the recursive call then, that we... No, wait. Wouldn't this work, right? If we don't do it recursively. Actually, let's science that. What happens if we do this? Instead of trying to write the full thing out, let's just see what happens if we try to load it. Right. Why did it break? Right. Couldn't match the expected B to A with the actual type. A0. Is it because I'm using I here? Does that matter? In an equivalent, in an equation for take, right, relevant bindings include right. I'm doing something wrong here, but I don't know. It's a syntax error, right? You say you take 2 parameters, but in the pattern matching you only have 1. Oh, right. Right. Thanks. I forgot about that. Right, we have the list and then we have n. Yeah. I completely forgot about that. Right, we have list and n. Which would mean we need to use n in here as well. Do you have a character? What if we just do one thing at a time? All right, one thing at a time. Make sure that it works. All right, we remove all this and we add a number later. All right, we just take a list and we return a list. Let's try and see if we can do that first. All right, that doesn't work. Because I need to remove this as well. All right, here we go. We take a list, we return a list. All right, so here... Let's see. The error we get is error occurs check cannot construct the infinite type. Right, in the expression x. Yeah, I don't understand this error message. It bothers me. I feel like it's often that way in the Haskell error messages. I have no idea what's going on in the error message. Alright. Right. I feed A to it. But you have a list of characters. Wait, oh. Oh, right. How do I... this cannot be a list of characters, really? It's any type. Why can't I have a list of characters? Because it has to be the same list of characters that I feed it. So how do I do this, right? How do I do an end thing? Do I just return an empty list? No? That's not what it's complaining about. It's complaining about this. Huh. Yeah. Exactly. An empty list is how take does it. But that's not what error message is about. This error message is about X. First check. Cannot construct the infinite type. I don't know what this means. It must be my list comprehension syntax that's off. Yeah, that's a mess. Alright. Let's do some cheating. What we do is that we go to table of contents. And we go to list comprehensions. Right. A mess is a strong word. Alright, it needs to... Yeah, I don't get why this is a mess. Even when I'm looking at the list comprehension, right? We have here, that's my I, that's it. And then we have it here again, where, right? I, where I is, right? What do we feed into it? X. Oh, it has to be a list, doesn't it? This has to be a list. So maybe I don't need a list comprehension. Maybe that's the thing. I'm just mistaken. Because I don't need to iterate over it. I just say that... What, like this? Alright, and then we take a list of where we have 1, 2, 3. Yeah, alright. That's how it's done. So maybe I don't need a list comprehension. But we don't even do it like this, because what we do is that we do it like this. And... Right, now we need to make it recursive. Yeah. Aaron Sarah says, nice, you got social credits now. Yeah, thanks for the tip. We do indeed. We got some Linux emotes as well. Very nice. X is the head of the list. Exactly, that's what we want. We want the head of the list, but we want to call it recursively. Yeah. So what we do is that we take... No, not take. What do we... Yeah, take... Take the head of the list. No. Shit, syntax. Damn it, syntax. Aaron Sarah says, yeah, you have GNU emotes that's only available for tier 3 subs. Yeah, I only had 3 spots. Wait, can't... Can't anyone just unlock the GNU emote? I thought that is how it worked. If you had the points, you can unlock the emotes. Alright. This is gonna turn it around, isn't it? No, since we're doing it recursively, it's fine. We add X to... No, not this. Not an empty list. We add it to the new list. So how do I... Is this just a new list? No, we need to call XS in here. We need to call the tail somehow. That's the recursive thing, right? That we use the tail. So what we need to make sure is that we add X into... Wait, is that it? No. Shit. Fucking recursion, man. Ugh. Yes? Is that really it? No, that can't be it. No. What about this? Oh, right. No, this... No, it's the wrong order. Take needs to just go on the tail. Tail goes... There we go. And... Shit, how do I do that again? Actually, I'm gonna do a little bit of cheating here. Right, where we do... No, I don't want to. Plus plus, is that what we're gonna do? We have to join two lists together. Man. Aaron Sarah says the only thing you can unlock with channel points is the thing with the flag, and it's only available for 24 hours. Oh, wow. That's... I thought it was just unlocked. Alright, so we take XX... No, we take... Here we go. We make an empty... Here we go. We make a list that we join with this list. Is that it? That means we should, by now, get just a copy of the list, right? There we go. There we go. Finally. Alright, you can use colon as you only have one element on the left side. That only works. Oh, I can do, instead of joining them together like that, I can just do this. Yeah. And I assume this is the better way to do it. I assume this is more optimized. Oh, I like this. Now we just need to put in the rule, right? Where we take... where we add the num b, actually. Could be even worse and say that it has to be an integer. Yeah, integer b. Then we take, all right, B, right. Do I have to have both the list and the number in here? Because of what I want to test is what the number is, right? XS, and then we take n minus 1. No, this just works, doesn't it? And if... Ah. Is that how it's done? No. Oh, shit. I forgot to do this. Integral, not an integer. Integral was... think. Alright. This is wrong still. Okay. What about trying if we just do... Oh, right. It can't be n, it has to be 0. Yeah. Right, if we take that, what do we return? Just an empty list? That's maybe how it's gotta look. No. Oh, no. This works now, it seems, right? Because we have 2 inputs. The first one we don't care about, but if the second one is 0, then we just return an empty list. And that is what we want to do. Yeah. Now this one, however, is broken. Right. We take the list and we return n minus 0. Wonder why it's broken this time around. Colgate InnoTab says you can have only the list, but then it returns a function and GHCI doesn't know how to show it. Aaron Sarah says you should put a programming tag. Maybe. Order of operations. Ah, order of operations. Right. Is this enough, or should I fix it even more? Maybe I should do like this, just to be extra clear. What did it say? Could not deduce num A arising from the use of minus from the context of integral B. Bound by the signature type 4. Okay. Let's try again. Oh, it works. Is this it? Are we done? Maybe we should put a programming tag. Right, so now we take... Actually, we can just do this again. And we just take 2. It works. Oh man, that took a long time. I think, though, we have a problem. Yeah. We do have a problem. We did not put an edge condition where n is longer than the list. So we take another edge condition. Is that how it has to be done? Where we don't... No, we do care about the list. That's a list, but we don't care. No, we do care about the number as well. But the number can be any number. And, right. How did we get the length of a list again? Because we want to just check the length of the list. I don't remember the name of that function. Aaron Sierra asks, what were you doing with the Assassinate channel reward? Oh, did that show up? I thought that was a secret. I have plans. I have plans for the Assassinate. With the whole meme. Do you want to hear the spoilers? Oh, it's gonna be a while. My plan was that you could do the Assassinate and that would time out someone. Yeah. And you could choose to assassinate someone else in the chat, and by doing that you would time them out so they can't talk for like 2 minutes or whatever. Holgetinotab says you don't need it. The length of the empty list is 0. Wait. How do you mean, right? If we go from 4 here, we go down. Through an exception. Yeah, when we go from 4... Right, we need to make sure that... Wait. Can I just do this? No, I was thinking that we add 0 here? No. No, I'm confused. What do you mean? We need something, right? We need to add another edge condition. This is the edge condition where... we want... What I want is that when we choose 4 here, I want to return the full list, right? I don't want to throw an exception. I want to just return the whole list, and we need Don't we have to test? No, we don't have to test for equality, but... Wait, if I just do this then, right? That's how it's done. Is that how it's done? No, it still throws an exception. Int add another pattern that returns an empty list. That was what I was doing, Colgating on tap, and you said not to do that. You said I didn't need to, and I was like, wait, why don't I? All right. Take. And it should return. All right, it should return an empty list again, but this time... Right. Oh, so when we return an empty list, we... Wait, no, this doesn't... Does that work? No. That looks weird. Let's test it, though. Oh, it does work. I don't know why, but it works. Alright, so that means that, alright, when we reach 0, we return an empty list. And if we return an empty list, we return an empty list. Wait, is that what's happening? I'm confused. Oh, sorry. Shit. Length of an empty list is 0. Aaron said, as a mod, I review the requests and queue and accept or reject them. Ah, nice. Don't know what that is about, though. There it is. Yeah. It's timing out people. I thought that was going to be fun. Add another pattern. All right. You don't need length. I did not need length, but I don't know why. There are two ways take can end. Number goes out or list goes out. Now we have both covered. Right. Right. Exactly. These are either the list is just like, whoops, there's nothing here. That's the edge condition, right? There's nothing in the list, or the number is too low. That's the two edge conditions. Oh man. Haskell is hard, dude. It's one thing you're reading about it and then writing it out, working within it. A lot of work. Gotta do more practice. We should try to do that some more to get into it. Yeah. Aaron Sarah says, sorry, I don't know anything about Haskell. You know that it's hard. Well, either that or you know that I'm terrible at Haskell. So you do have some knowledge about it. Well, one of those is knowledge about me or Haskell. It looks like mathematics, I suppose. Alright, let's see how they did it. Where were we? Here we go. They did it differently, didn't they? Yeah. For instance, take 3 will return 543. If we try to take 0 or less elements from a list, we get an empty list. Exactly, yeah. Also, if we try to take anything from an empty list, we get an empty list. Yeah. Notice that those things are edge conditions right there. So let's write them out. Why did he put a guard? Right. We take n and the list doesn't matter. If n is smaller than greater... Oh, actually, yeah, a guard would be good, right? If someone gives us a negative number, my list breaks, doesn't it? Yeah, if we take like my... Yeah. Is there a type class for just positive numbers? I don't remember. Because an integral can be negative, right? One way of doing it would be just to decide that we just want... Is that like natural numbers or something like that? Colgatinontab says that Twitch changed how bans work. Now timing out someone automatically makes them unfollow. Oh no. That is not good. I agree, Aaron Sarah. That doesn't work. Banana Wolfmonkey asks for a quote, so... You're dumb. You can't make decisions for yourself. Consume, obey, submit. Amazing. Alright, so how do I do... That's a good question. If I want to find... a restriction like this. Actually, what is the best way to do it? Is it doing it this way? But this is creating an extra test and is not optimized, right? So the best way to optimize it would be to take an... right, instead of having num type class and ordering type class and making this test. Wait, I'm just assuming here. Is pattern matching better than guarding? Why would pattern matching be better than guarding? Because it's less text? Banana Wolf Monkey adds the quote, remember the Stanford prison experiment? Yeah, remember that. That's important. Yeah, I wonder. What is best? Is it best to make restrictions within the type class or within the function itself? They did it within the function itself. Right. The benefit, if we look at the user, right, in the use cases, if I put a restriction and make sure that the numbers has to be positive, then they have to be positive, otherwise I throw an error. While if they come with a negative number, they return an empty list. So it depends on what you want to do. Do you want to throw an error, or do you want to return an empty list? And I think I would prefer like the functional way if we're talking about no side effects. Then I would argue that if we don't want side effects, we should not allow for negative numbers to be used in this function. Right? Because returning an empty list is not what we asked for. We ask for something impossible, and therefore we should throw an error, I think. Alright. So then we just check Haskell. Positive numbers type class. And let's... Oh, shit. No. Positive... Oh, I can't spell for shit. Alright. Positive integer type. Here we go. Make some check during compile instead of runtime, so I want to implement as simple checks as possible. Wait. Wait, someone is making natural number. Wait, actually, let's do this. Haskell type classes. Do we get a list of all of them? No, I don't want to. I want just like a list of type classes. All type classes. Is there a way to find that? It doesn't matter. I don't want to make my own type classes. I just want to see a list of all type classes that are included in Haskell from the get-go. I want a reference. Type class reference. Yeah, Haskell type class reference. I guess not. That would be a good resource. Just list, these are all the type classes. Aaron Searer says, report side or McDread's mode. Makes me pay for GNU when it's open source. Oh man, yeah. I don't know if... how I could change it around. Wish everybody could get all the flags. But I don't know. Alright, we can just live without this for now. But I would argue that that would still be the best way to do it. Unless, of course, you have to well, maybe constructing your own type class would be redundant in an easy function like this. But if we want to scale it up, I would argue this is not the way to scale up. Yeah. Aaron here says, can you only put one emote in each subtier? Yes, exactly. That is what happened. Only one emote per subtier. And there were 3 subtiers, and I put 3 emotes in there. I think, however, I could automate and make the bot shift places on them. So whichever emote is in the tier 1 that you could, I could probably make the bot choose which emote you would want. I don't know. Welcome back, Melanol the Destroyer. How went your shopping? Your says you replied to that faster than you ever have. I'm surprised. Wait. When you gave my... It's big red text. Melanol says, I'm gonna fix you now. Oh no. Part of me just wants to... want to reject this. Okay, Melanol the Destroyer says, Melanol 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 says. I don't know why I did that. It's just the completionist in me, I guess. It was awful. It was awful. Alright, let's just check it out. But they were doing, other than this difference, we were doing the exact same things. Even though my edge case was a bit off. Yeah, I didn't account for negative numbers. Yeah, I was just thinking that only me in this way can put it to 0. The user would never do anything stupid. Yeah, the user always knows what they want to do. Trust the user. They know what they're doing. Alright, the first pattern specifies that if we try to take a 0 or negative number of elements, we get an empty list. Yep. Notice that we're using the underscore to match the list because we don't really care what it is in this case. Indeed. Also notice that we use a guard but without an otherwise part. That means if n turns out to be more than 0, the matching will fall through to the next pattern. Right. Yeah, the way to stop this, if you only want to have one guard structure and no secondary pattern, you have to use otherwise. Well, don't have to, right? But maybe. Man, Melanol the Destroyer says, now your neurons are more likely to pronounce only Melanol. Well, you know, since you were annoying and made me say, well, you didn't make me. Since I said all that stuff and found it annoying, it was like reverse psychology, Melanol the Destroyer. You tried to get me to only say Melanol, so now I'm more likely to say Melanol the Destroyer. Oh man. I thought that was funny, I'm sorry. The second pattern indicates that if we try to take anything from an empty list, then we get an empty list. Yeah, that's the one I forgot to think about. And Colgate InnoTap made sure that we fixed. Aaron says, what is Melanol? Uses. Hydroquorine is used to lighten the dark patches of skin, also called hyperpigmentation, melasma, liver spots, age spots, freckles, caused by pregnancy, birth control, pills, hormone medication, or injury to the skin. This medicine works by blocking the process in the skin that leads to discoloration. Yeah. I remember, that's how we met. Melanol was going around having this username for quite a while and just suddenly got banned from all the places because of that new medicine. It was, I mean, a little bit funny, I guess. That's amazing. Right. Banana Wolf Monkey says, I suppose it is appropriate since you were just talking about recursive functions. It is appropriate, yeah. Lunchtime? Not yet, no. I like that. Melanol says now. Melanol changed his name. So now, yeah. Actually, part of me was to mess with you even more, but that was funny. Yeah, I like that. Right, the third pattern breaks the list into the head and tail. Yeah. They just took it in the other order. They took the number first and the list second. So I took it in the wrong order. Should have taken the number first and the list second. Yeah, take 3 from. Right, and then we stay taking n elements from a list equals a list that has x as the head, and then a list that takes n-1 elements from a tail as the tail. Try using a piece of paper to write down how the evaluation would look if we would try to take, say, 3 from 4, 3, 2, 1. Yeah, right. We would have to write this down. Right? This is just what we write down. It's exactly this. Not exactly this, but almost. It's very similar to this thing. Right. Reverse simply reverses a list. Think about the edge conditions. Edge condition. What is it? Come on, it's the empty list. Yeah. An empty list reversed equals the empty list itself. Okay. What about the rest of it? Well, you could say that if we split a list into a head and a tail and then reversed, the reversed list is equal to the reversed tail and then the head at the end. All right. Should we do this as well? Try to make our own reverse? Right. Reverse. We take any list and we return a list with any type. Sorry. We take a list of any type and then we reverse. Our edge condition is an empty list, of course. So that returns an empty list. No. Is that it? Yeah, that's probably fine. All right. And then reverse. We take the head and the tail of the list. And right. Then we right, we gotta stop with the X, right? We put the head. We put the yeah, we take reverse XS. Is that just it? Oh, I have to make sure that this is a list. This is not a list at the moment, is it? No? Wait. Yeah, like that. No? Banana Wolf Monkey says you can have infinite lists. We can, yeah. Could that also be an edge case? An infinite list? Not in these examples, I don't think. Oh, maybe this one though. No. This one is fine. An infinite list would probably break the reverse though, yeah. It would create an infinite recursion, yeah. Oh, right. Can't use this because we have XS is not one thing. It's a list. We're putting two lists together. Thanks, Colgate in on tap. Yeah, we're putting two lists together. We're not adding an item into a list. There we go. Melon all the destroyers, it can't be an edge case if it's impossible. Right, oh, right, you changed, so now you have the... You forgot to have the capital M in the name. I thought there would be some kind of restriction on how often you could rename, change your name. What did you say, Kappa? All right. Melanol the Destroyer asks... Oh, sorry. Is this gonna work? I think this is gonna work. Yep. That was a little bit easier now that we got it down, right? When I could use this as an example, this became way easier because I just used the same syntax again. There is restriction, but not on capitalization. Oh, nice. Easy mistake to make, right? With the capitalization thing. Alright, so what we do is we call reverse on the list 1, 2, 3, and it works. The problem is... Alright, let's watch me burn my computer to a crisp. Do I need the 2? Alright, 1, 2. Let me burn my computer to a crisp. There's the fan going off. Oh, look at that. I think, yeah. It threw an exception before I managed, right? It threw an exception and then I cut it out. Yeah, I tried to cancel it, but that's my cancel. It canceled itself. That's very kind of it. Very kind indeed of the interpreter, just saying that, whoa, what the fuck are you doing? Stop doing this. Stack Overflow? Not okay. Alright, so one way we could be... we could make our own edge condition, right? We could be responsible people. And we could add our own, right? Reverse and right. Shit. No. How? If we call reverse, how do we check for length again? There was a function already, right? Is it just length? Is that how you spell it? No, that's not it. Was it lm? Oh, and this needs to be a guard. Yeah, this needs to be a guard, so... shit, how did we make a guard again? Alright. Oh. Right, and we take that... No. Alright, sorry. We do just take XS, and here we take LM XS smaller than, no, greater than like 1000. And what we do then is, sorry, this list is too long. Oh, it is length. All right. LM just checks if there is one off it is. All right, so length. All right. Does that work? Was that not how you do it? Oh, I thought... I thought we didn't use equals in the guards. I feel like I remember complaining about that. Maybe I was mistaken? Oh shit, where are we? There, alright. Slider joining cancel culture. Wait, what did I say? I don't remember. That error means you probably copy-pasted your code from Stack Overflow. Nice. I love that, yeah. Definitely. Length, alright. Google.haskell.org is good for looking up functions. Nice. Equal and error. Don't return a string. Shit, right. Same mistake again. Like I did before, trying to return a string. Alright. I can, however, return an error. Right? I think that's what he did before, right? Returning an error. Yeah. Right, reverse. Oh shit, it doesn't. Wait. You can't get the length. Yeah, I can't get a length of an infinite list, so it doesn't help me. I wanted to stop an infinite list. I mean, I could just... Yeah, I could just go like this. I can stop this list. Yeah, I can stop that list. Or, well, an exception rather than an error. But it doesn't stop an infinite list. Damn it. Melanol says, do you like what you see, Kappa? I don't like it. Just took random capitalization. Oh. Right, length also takes quite a while. Oh, does it? Oh, yeah. It's a problem in here, isn't it? In a functional language, doing something over this way. And since we can have infinite lists, is that just something we'll live with in Haskell? That we don't deal with it? It's like, well, this is not my problem. The infinite recursion? It's not my problem. Is that it? If you're dealing with infinite lists, then that sounds like a you problem. Melanol says, don't you want to say unlimited instead of infinite? Infinite would take infinite memory. No, it is an infinite list. That's a benefit of a lazy language, that it is an infinite list. Because it's a lazy language, you can have actual infinite lists. or unrestricted. No, it is actually infinite. It goes, right, when we do a list, where did we try that? Right, when we do, whoops. We do a list like this, 1, 2, ... That goes on forever. This is an infinite list in a lazy language. Benefit and a problem. Here we go, we got the Hoogle thing. Welcome to Hoogle. Hoogle is a Haskell API search engine. Nice. Which allows you to search Haskell libraries on Stackage by either function name or by approximate type signature. The Hoogle manual contains more details. Alright, we can look into that later when we need to, I guess. The next time we need to look up that. And this was when I thought I needed list comprehensions, but I did not. I did not. Melanol the Destroyer says, it is not infinite. I know math. I thought it was. I don't know math. I don't know Haskell, so I don't know. Yeah, we did it the exact same way, right? Oops. Reverse says reverse x's plus x. Yeah, exactly. There we go. Because Haskell supports infinite lists. Oh, here it comes. Infinite lists. That's what he calls it. Our recursion doesn't really have to have an edge condition. But if it doesn't have it, it will either keep churning at something infinitely or produce an infinite data structure like an infinite list. The good thing about infinite lists, though, is that we can cut them where we want. Oh, we can. Repeat takes an element and returns an infinite list that just has that element. A recursive implementation of that is really easy. Watch. Repeat. Yeah, that's super easy. That's a I was gonna say that it's a problem and I didn't want to, but yeah. Infinite data structure. Ah. Colgate InnoTab says, I know some math. Wait, some? I think you're selling... what's that? I think you know more than just some math, Colgate InnoTab, yeah. And some Haskell. They are infinite. Yeah, that's what he's saying, that they are infinite lists. Right, calling repeat 3 will give us a list that starts with 3 and then has an infinite amount of 3s as a tail, yeah. So calling repeat 3 would evaluate like 3 repeat 3, which is... Yeah, exactly, which just goes on and on and on. It will never finish evaluating, whereas take 5 repeat 3 will give us a list of 5 3s. So essentially, it's like doing replicate 5 3. Oh, that's how you cut an infinite list short. Not what I did. What did I try to do? Oops. Yeah, I tried to go for the length of the list. No, instead we just... Right. Actually, I think I did this... No, I did change this after a while. Let's see. How would I do that, right? I would just... Right, what about if we try... Like, I just want to try something. If we take 3 from a list of 1, 2, 1, 2. Oh, it works. Yeah. So what I could do is just... where do I put a take somewhere in here? In this one? I could probably like do this. Take 1,000. That would be a better solution, right? If I wanted to cut the list short. Make sure I don't end up with an infinite list. Or maybe even in here. Maybe it would have been better in here. Yeah, it would be better in here. Yeah. We would do this. Take 1,000. No, shit, this won't work, I don't think. I think the first one is the one to go with. Yeah, this won't work. There it works. Right, now we try to reverse an infinite list. 1, 2, ... There we have it. Colgatino tab says take 1,000, but then it gives the wrong result. Yeah, it gives the wrong result. We would have to rename it, yeah. Rename the function, make reverse, call it with take 1,000 on the list. Yeah, I took 100 now, but that's fine, right? If we want to put a limitation within our function, yeah, we could. We could make sure that we don't end up in an infinite recursion, because an infinite recursion would be sad, wouldn't it? All right, how far are we? All right, let's just read the rest of them. All right, zip takes two lists and zip them together. Zip 1, 2, 3, 2, 3, right? Right, into tuples, yeah. Because it truncates the longer list. Because it truncates the longer list to match the length of the shorter one. Yeah. Oh, right, this one just disappears. How about if we zip something with an empty list? Well, we get an empty list back. Then, so that's our edge condition. However, zip takes two lists as parameters, so there's actually two edge conditions. Right. That's the thing that I missed out on before. When you take two parameters, yeah, two edge conditions, indeed. Right, the first two patterns say that if the list is to the first or the second list is empty, then we get an empty list, indeed. If the third one says that two lists zipped are... Wait. Are equal to pairing up their heads, then... Wait. The third one says that two lists zipped are equal to pairing up their heads and then taking this zipped tails. Exactly. It's a function, yeah. That this is equal to this. Zipping 1, 2, 3 and AB will eventually try to zip 3 with an empty list, which will reach the edge condition. Right. The edge condition pattern kicks in, and so the result is... Which is exactly... Yeah. So you could, right? I was thinking about this when reading about the zip. What if I want to take 3 with something else? You could make a different edge condition here. Right, that you return an empty list only when both lists are empty. Oh, you would have to make a lot of edge conditions though, right? You would have to make one for when there's only things in this list. And one for when there's only things in the... So, no, you would only need 3 edge conditions instead of 2. Yeah. Let's implement one more standard library function, elem. Right, it takes an element and a list and sees if that element is in the list. The edge condition is, as most of the time is with lists, an empty list. We know that an empty list contains no elements, so it certainly doesn't have the droids we're looking for. Alright, and in this one we make a guard function. Wait, first the edge condition... Oh, right. Since it's a boolean we return false if we get a and an empty list. Oh yeah, the element. Right, and if a is equal to the head, yeah, exactly. Otherwise, we just call it again with the tail. Alright. Pretty simple and expected, yeah. If the head isn't the element, then we check the tail. If we reach the if we reach an empty list in our recursion, then we return false. Right, there we go. And we do one more recursion day tomorrow where we go into quick sort. Colgatin on tabs said, yeah, 1 edge condition more. Indeed, yeah. That Star Wars reference got me off guard. It was right there. Just... It's not the Star Wars reference you were looking for. And also we're talking about the guards. I don't know if that was an unintended pun. But that's it for today. I think I feel more confident in recursion now that we actually did it ourselves instead of just reading about it. Yeah. So gotta pay attention to that and do some actual practice instead of just reading. Alright, so thanks for hanging out and yeah, have a good one and see you next time. Yeah, cheers.